I think it was around the year 1975 that I started taking electronics classes in high school. This was in Germany, and our teacher was a big fan of products sold by EDI, which I think was a Chicago-based company, but I'm not positive. I think EDI stands for Electronics Distributors something or another. Industries International, I don't know. I tried looking it up and didn't find a good answer. This is just a shot of the front of one of their catalogs. This is from 1972, and it's just something I found on eBay. The reason I mention this is that we were encouraged in the electronics class to try building a few kits and get some practice building things. And since I was one of the founding members of the new electronics class, I had been part of the group of students who came in before the classes started. I think this would have been in the fall of 75. Yeah, the fall of 75, or in the summer of 75. And started building all the Heath kits that the lab had purchased so that we would have actual test equipment for the lab stations in the fall of 75 when the actual classes started. So I'd already built some pretty big kits, but we were encouraged nonetheless to buy a variety of things. And some kids, if they had the money, were actually buying more Heath kits. I remember several kids bought a little monaural audio amplifier, built that. They all thought that they were getting like a big powerful guitar amplifier or something. They had no notion of wattage or anything, but it still makes me laugh today. But the reason I bring this up again is that one of the kits I bought was a digital clock. And since I only remember ordering things from EDI, and the teacher would have a copy of the catalog, let us peruse it, then he would write up a massive order, and then when the kits came in a big box, he would distribute them to the students who had ordered them. And so I built this digital clock, and I used it, I'm sure, through college, until I think I replaced it with a Heath kit, a digital alarm clock that had a green vacuum fluorescent display. But up until that point, yeah, I used the kit that I'd bought from EDI or somebody else quite successfully. It was very accurate because it was AC line synchronized. The only problem was it was not an alarm clock, so it wasn't any good for getting me up in the morning, and I had a old-fashioned wind-up alarm clock with actual bells on the top of it that I used for that. So the real subject of this video is that alarm clock. And here it is. This isn't the kit itself. This is something with a unskilled teenager's shop talents I put together, and the kit is just that little part inside of there, really, but I surrounded it with this box. All I had was scraps of plywood and some, looks like some masonite. I think I borrowed my parents' Dymo label maker for the labels. I think that the switches and buttons did come with the kit. I'm pretty sure that the line cords did not. I have no idea where I bought these cords. And they're different ones. I had one cord for the, I probably cut it off of an old lamp or something. And where I would have gotten a few inches of zip cord beats me. Maybe they sold it at the store I frequented, just don't remember. Luckily, we did have a store that was run by the U.S. military, and we could get some things. Otherwise, in Germany, I wouldn't have been able to get a zip cord like this. Now, at the time of making this video, I'm on the cusp of retirement from my day job, engineering job I've had for nearly 35 years. And that was my third job after college. I'd worked in a different business for about 9 years, and then as a consultant for a good part of a year, And then the company I'm just now retiring from, that's in material handling and power generation and wastewater treatment and so on. But I had this clock. I thought it was lost, and I think my mother or somebody was having somebody clean out their attic and found a cardboard box up there, and sure enough, this thing was in there. And I took it home and put it in storage for a number of years. Then one day I hauled it out and said, I wonder if this thing works, and I plugged it in and it worked just fine. I said, well, I'm taking this thing to my office. And then for a number of years now, I don't know how many, I would say at least 6 years, maybe more, I've had this running on my desk in my office, just, you know, as a conversation starter, really. People knew I did a lot of work with electronics, and sometimes they'd come over to chat and they'd say, what's that thing? And I'd say, well, that's the first kit that I built, you know, which wasn't completely true because I didn't mention the Heath kits. But one that wasn't a complete kit, it was just a partial kit. I'm sure this is the first one of those. Now it's kind of dusty. I'm going to do a little cleanup on it, then I'm going to demonstrate it and discuss the circuit. Alright, this is more cleaned up, dust removed, and I still kind of marvel at, I mean, this is a really crude case, but, and it's worn and showing its age, but I think I did pretty well considering I had essentially no tools. I do remember, you know, ransacking around and finding some scraps of plywood here or there. I probably dumpster dived or something to get some of them. I don't know where I got the piece of actual glass that's on the top or how I cut it. Obviously I was able to cut it to size somehow. And the front is some sort of acrylic, I don't know. Well, it might be Lexan, it might be plexiglass. It's a pretty thin layer. And again, the rest of it's plywood, but to make it look a little prettier, I remember that my mother always was a big fan of contact paper. Wonder if they still make it. But she would use it to dress up all sorts of surfaces, so I'm sure I ransacked her stock of scrap contact paper, put these yellow panels on the sides, and the wood grain stuff on the plywood. And to inset the glass and plexiglass panels, the slots are too narrow to have done with a circular saw. I probably just sat my dad's old hand saw on there and just, you know, chewed away at the wood with that. That would be my guess of how I did it. I might have actually cut the plastic the same way, although the edges look very smooth. Maybe I scribed them and bent them over a table or something. And the glass isn't square. It's kind of goes down at a bit of an angle. I didn't do a real precise job on that. Anyway, I found this plastic box somewhere. Looks like it had a place for a label. I don't know if it was a little drawer or what it was, but the kit, as I recall, did come with the little power transformer. When I built this, I probably didn't know it was called a power transformer, so I labeled it AC converter. 117 volts to 9 to 13 volts. Probably is what it said right on the transformer. And it just gave me a safe place to have the line voltage. Held it shut with electrical tape. Actually, yeah, look at this. You can see I did it in Germany. I think this was a box that probably held screws or something. And I'm sure I picked this up at the German hardware store where I bought some things. You can see some of the German text on there. Well, I'm going to flip this around on the back. And I had 2 push buttons on there. The one under this label is the slow advance, and the one down here is the fast and I think reset. I'm guessing that's what it means. And then you've got 12 and 24-hour mode. I think I probably had a 24-hour label on there. It's currently selected to 12-hour mode. The switch is originally designed to be a 115 230 volt selector for incoming AC power to something, but I think the way EDI did a lot of these kits is they just threw whatever they had surplus of and populated the kits with them. And this is, you know, obviously a light switch, but it's used as a hold run switch here. I was rather pleased with myself that I had put a schematic diagram on the back. Operate on 60 hertz power, connect loose green, I think is wire, but some of the letters have worn off. Connect loose green wire to hold switch, same terminal as pink wire. And that's because I built this originally in 50 hertz mode because it was in Germany. And I made that note there so when I came back to the States I would remember how to change it to 60 hertz mode. So it shows the incoming AC power, the power transformer. There's a bridge rectifier. They're using 1N4001 diodes, but the bottom half of it's rubbed away. And then there's some kind of a something or another K resistor. The left-hand side of the bridge, that's the minus side of the bridge, just goes to circuit ground. It's kind of rubbed away. The positive side goes to a capacitor, electrolytic. If there was a value there, it's been rubbed away. And then to get the AC synchronization, it taps off one of the AC sides of the bridge. Again, it's something or another K resistor, probably a fairly high value, and looks like a 0.01 microfarad capacitor to circuit ground. And then that goes into pin 16 of the IC, which is a National Semiconductor looks like 5314N, single chip clock IC. And then the AC, or the rectified and filtered but not regulated. Oh, there's the capacitor value up there. I wrote it up there. Comes down here and goes into pin 12. I didn't know about putting intersection dots, but I'm guessing that that diode there is to clip the AC waveform. So I believe that 1N, was it 814 diode, or maybe it might actually be 914. I just put a loop on the bottom of the 9, and 1N 914 is certainly a common small signal diode. And that would make sense because going to the positive power supply, it would clip off half of the AC waveform and leave you with just half of it. Pin 2 is grounded. Pin 10 goes to the 12-24-hour switch, the other side of which is grounded. Made a nice little diagram showing the segments and their arrangements on the LED displays, and their Fairchild FND70s, very common type, now practically unobtainium. Pins 17 through 22 are the digit enables, and they go to a bank of PNP transistors, the collectors of which are common to circuit ground. Those are the digit drivers. And so these are, I think that, let's see, yeah, the current's flowing out of them, so they're common cathode displays. And let's see, and then all the segments come out of a bank of 270 ohm resistors and go into NPN segment drivers, the collectors of which are common together. I'm calling them A here, and those come right off of the positive power supply right there by pin 12. Then the only other things on here are the hold switch, the slow, and the fast for setting the time, connected to pins 13, 14, and 15, and going to circuit ground. I mentioned that all of the Q1 through Q7, those are the segment drivers, those are NPNs, and it's a 3904 or a 3392, and all of the digit drivers are 2N3906s, again, very common parts. And I restated that the displays are FND70s. So that's the whole circuit, pretty simple. I'm going to see about opening this case up now and getting a better look at the inside. There's my teenage genius method of holding the circuit board in place. I put in nails, 2 in the back and 1 on each side, put them in at a bit of an angle so that it would slot the board in when you put it down, and then looks like I snipped off the heads. Fairly pleased with myself for coming up with that when I was that young and stupid. So my soldering skills were not excellent, and I had a very primitive soldering iron, but they're serviceable connections. There's a couple things that are on here, such as capacitors across the push buttons, which are not reflected on the schematic. And I guess that these wires probably came with the kit. They probably just gave her, some scraps of wire, something they had surplus on and were using to populate the kit. Fairly narrow gauge. I'd say it's even smaller than a 22 gauge. And yeah, the IC socket is 4 pins, or 2 pins on each side, bigger than the IC. So that would have been typical of what EDI would have done when they sold these things. Oh, we got some surplus on these bigger sockets, just throw them in there and, cut off the unused pins. No need to spend any extra money to make it nicer. It worked. So there's all the segment resistors, 270 ohms, and the segment driver transistors. And there's a couple of these capacitors. And then the digit driver transistors, the 4 diodes for the diode bridge, a couple more resistors, the main filter capacitor, and that's all that's on it, really. The parts are identified on the foils. I don't know if I had to drill the holes in these. These might have been ones where you had to drill your own holes in the circuit board. And there's the green wire jumper that determines whether this is 50 or 60 hertz. And it looks like there's a foil cut here. These things usually came with very perfunctory manuals, and the kit was, I'm sure, designed to be sold in the US, and there probably wasn't anything in the manual about how to make it work at 50 hertz, so I don't know if my instructor looked at a data sheet and said, hey, here's how you make it work at 50. You have to cut this foil, and then when you want to make it work at 60 again, you got to put this jumper in, or if I figured it out by myself. I just don't recall. But, the solder joints aren't horrible on here. Nothing to be ashamed of, at least. Okay, I'm going to power this guy back up. You can see that not all of the segments on all of the digits are working. That lower right segment on the second one from the right is kind of iffy. works sometimes and not other times, but I don't think it's the output of the chip, because those same segments work on other digits. So I don't know if it's something intermittent. Yeah, like that lower right segment is working now, but it doesn't always work. And now the lower left one here isn't working. It should be a 0. We'll see if it turns on when it changes to a 2. Yeah, it doesn't. Something is flaky, especially with that digit. That's the one I mostly notice it on. Yeah, now the lower right one doesn't work when it's on a 3. I tried to find some replacement FND70s for this, but I came up short. So yeah, it'd be nice to replace all these with new old stock, but I honestly don't plan to use this for anything. I don't have a place to use it in my house, and with no office to put it in anymore, yeah, it's probably going to go back into storage in my basement. So this is really just a sort of a last hurrah for it. I may never turn it on again after this. But let's see if I can set it. It's about 9:34 here. So I'm going to put the clock in hold, and that freezes it. And then slow and fast, so I can get it to, I'm holding down the slow, and now it's up to 9 already. And I just burped that should be 30. I'm up to 37 already. This is pretty fast. That's really fast. Oh no, those are seconds on the right. Okay, yeah, so I need to get it up to 9. So I'm going to push fast to get it up to 9. Now I'm using the slow button. Don't want to overshoot it. Oh wait, no, I got to go to 35. I can still go fast for a little bit. Oop, there we are. Go back to slow. And it's just rolled over to 36. I went a few seconds over. The reason the hold switch is there is so you can actually set it ahead slightly. And then take it off of hold and let it start running at that point. Actually, now I'm only about 3 seconds off. Like I said, this clock chip doesn't support an alarm function, but it does make a very accurate clock because it's synchronized to the AC power line, and the power company keeps those very accurate. They monitor and adjust, so they may have little blips in the accuracy in the short term, but in the long term they're always held very close. So if you set an AC synchronized clock, it will always be, you know, in time. It's not going to drift fast or slow like something that's crystal based would, like a, you know, typical wristwatch or something. And of course this was in the days before GPS synchronization. Well, I hope you enjoyed this little nostalgic revisit to this old kit.